Hi students, in this session I am explaining about vernier calipers, which is also a very important concept in units and measurements or units and dimensions, which is also a scoring topic. If you know a very basic fundamental concept or foundation concept from the beginning level, you can easily answer the question which is asked in JEE mains or in NEET. We classified units and dimensions into 12 parts. This is one of it, and we will learn it thoroughly in this session, and later we will do PYQs on it. So introduction to vernier calipers. First of all, the definition: a precision instrument used to measure internal and external distances with high accuracy. So with scale or with meter scale, you can measure the external distances like length of the pen or length of a pipe like that, but you can't measure internal diameter or inner distances. So vernier calipers is used to measure that internal and external diameters or external distances with high accuracy. So what is the purpose? Purpose is it overcomes the limitation of the standard meter scale, which can only measure up to 1 millimeter. Generally, in standard meter scale, you have 1 millimeter, which is the smallest division on the main scale. So you can measure the distances till the level of 1 millimeter only, but not less than that. So the precision is only 1 millimeter, not less than that. But using vernier calipers, we can easily find the distances, or you can easily measure the distances which are less than 1 millimeter also. So invented by Vernier in 1631. The precision is generally capable of measuring up to 0.1 mm or 0.01 centimeter, even less than that also. Some vernier calipers are designed such that they have least count or minimum division which is less than 0.1 mm also. We will come to know while doing this. This is exact shape of the vernier calipers, which has two jaws, main jaws or primary jaws, to find the external diameters or external distances, and these two are inner jaws or secondary jaws, which can be used to find the internal diameters. And it has a tail also, it is not seen here, in later picture you will have. So using the tail we can find the depths of the small objects, like for example if you consider a test tube, if you want to find the depth of the test tube, you can use that tail. And it has a main scale which is not moving, and you have a vernier scale which is moving on this main scale. Why should he take two scales? We will come to the exact concept here. So I will show you a picture to you right now, so try to examine that. So these are the divisions, seems to be same. If you find the difference between any division, you can mark on the paper. So for me, I can observe that this one is very smaller when compared to others, and this is a little bit bigger than compared to others. That's what my guess is. So when divisions of small discrepancy kept aside, our bare eye may not detect the proper difference. This is the main concept he found. Now I am sharing the exact divisions which are here. So all these divisions are exactly spaced. So now when you compare with this, so is there any discrepancy in the first one? So that means my bare eye did a mistake. And from here onwards, here I think, okay, here you have a discrepancy. All these divisions below are equally spaced, but when compared to the other one, we can easily find that a difference, slightly displaced. Okay, later on others also the same. So whatever guess I did with my bare eye, so I did a mistake. When compared with the other scales, we can easily find that difference. That's what the Vernier did, and thought about comparing the two precisely drafted scales, so that whatever discrepancy you will have, that will be measured, and so that we can find the exact distances to the utmost precision. This is the exact concept explanation how Vernier invented and all. So we will come to the device. So this is actually a vernier calipers measuring division, where you have main scale and a vernier scale. So he gave a principle that the vernier caliper works on the principle of vernier, which uses the difference between two slightly different scales to achieve high precision. So he had two scales, one is main scale and another one is vernier scale, which are spaced slightly little bit differently, and when comparing that one you can get the high precision where the exact difference is there. So main concept is it utilizes the fact that the human eye can align two lines coincidence much more accurately than it can estimate the distance between two marks on a single scale. So as we did in earlier slides, we did not observe different type of divisions when it is having only one scale, but when it is having two scales, when they are comparing, we can easily find which division is having that discrepancy. So it is the main concept of him. The difference, the instrument consists of two scales, main scale fixed divisions usually 1 millimeter each, and vernier scale a sliding scale on where n divisions are made equal to the length of n minus 1 divisions of the main scale. So he used two scales in which main scale is here, which is a constant scale. On it a vernier scale is sliding, and this vernier scale is also having some divisions. So in this picture you have 25, okay, but some have 10, some have 50 also. So that is sliding, and those divisions are matching with 1 less than the number of the vernier scale divisions on the main scale, so that we can compare each one by one, and so that we can move the distance at the comparison of the difference. That means whatever the difference that you are getting from each division of main scale and vernier scale, that much you can move, and that much level we can measure the distance of the object. We will come to know while doing the measurements using this vernier calipers. So here intentionally he injected a principle, that is a sliding scale where n divisions are made equal to the length of n minus 1 divisions of the main scale. So this is exactly principle, n vernier scale divisions is equal to n minus 1 main scale divisions. That is the exact principle set by the Prairie Vernier. We will use this one for further calculations. So in this slide I am considering 10 divisions of vernier scale, assuming that vernier scale has 10 divisions, which is matching with 9 main scale divisions, because if you take 10 VSDs, it should match with 10 minus 1 MSDs, that means 9 MSDs, okay. So that is what the principle says. So for that I am considering 10 vernier scale divisions and 9 main scale divisions which are comparing each other or which are matching each other. So here if you compare the scales, small discrepancy is there or small difference is there between one main scale division and one vernier scale divisions. You can observe that yellow lines, okay. So here the difference is little bit lesser, and later it is increasing, and at last totally coming toward the left, and at last it is matching with the last division. So here 10 vernier scale divisions are matching with 9 main scale divisions, so that we can get that small discrepancy. And if you move this vernier scale, because I said vernier scale is moving, right, when you are moving this vernier scale to keep the object between the jaws, this matchings will be happening, and based on the matching we can easily measure the discrepancies that many moved up. So for example, if I move a small distance such that this first division is matching this one, then what is the small difference? This much difference length is there between the jaws of the vernier scale, right. So based on this movement, whichever is matching with the main scale, that will be considered, and that will be evaluated for the measuring of. So this is what the physical thing happening over there. So vernier scale is sliding, while sliding it is going to match with the main scale. So that is what the working of the principle. So here parts of the vernier calipers, as I said earlier, here to understand the device we must look at its two main scales and functional jaws. Main scale, so this is the main scale which is fixed on the main jaw, and vernier scale which is sliding, this is the vernier scale which is sliding on this main scale, and lower jaws are primary jaws, okay. We can say these two are primary jaws or lower jaws, which can be measured the outer diameter or diameter of a sphere, like that. If we keep the object between the jaws and move this jaw, because this is moving, right, so by moving this one, and if we fix the object here by settling it here, and we can measure the measurements here on main scale and even vernier scale also. So these are the primary jaws, and these are secondary jaws or upper jaws, okay, used to measure the internal diameter of the hollow object. So assume that you have a pipe like arrangement. So if you want to find the inner diameter, we should keep these jaws inside and fix it and measure it. And next one, depth probe. So this is depth probe. As I said, it's a tail. So when you are moving, the tail also will move, and if you keep the tail inside the test tube or something like hollow objects, you can easily find the depths of that object. So that is depth probe, a thin metallic strip used to measure the depth of the containers. Next, thumb screw. So this one is called thumb screw, so which is used to slide the jaws and lock them in position. So after keeping the object, if you lock this one, these two are, this is for moving and this is for fixing. So after fixing, so no more motion in the jaws, and then we can easily measure the, and these are the important formulae that we need to get from a vernier calipers. The accuracy of the instrument depends on two key calculations. One is least count. So as I said in the concept, least count is the least value that can be measured from a device, or minimum value that can be measured from a device. So smallest distance that can be measured accurately, it is also called as vernier constant. So for vernier calipers, it is called vernier constant. So the formula for that is least count is equal to 1 main scale division minus 1 vernier scale divisions. 1 main scale division minus 1 vernier scale divisions. Another formula is also there. 1 smallest main scale division, that means 1 MSD divided by total number of divisions on vernier scale. So number of vernier scale divisions. In earlier scale we have 10 vernier scale divisions, so we can keep 10 here, and 1 main scale division is, which is the smallest division on main scale. Here on main scale also we have smallest division, right? So that division we can take it as 1 MSD, and 1 MSD by number of VSDs we call it as least count. And next one, total reading. Total reading means the diameter of the object that you are keeping inside that jaws. The final measurement is the sum of main scale and vernier scale readings. Total reading is equal to MSR plus, it should be VC, okay, VC into LC. What is this MSR and what is this VC, and I will explain now. If you attach these jaws, the 0 of the vernier scale will match with the 0 of the main scale. When there is no object, these two jaws will be at contact position. At that moment, the 0 of the vernier scale will match with the 0 of the main scale. So when you are moving, to keep the object, when you are moving this sliding scale or vernier scale, so it will cross some main scale divisions, right? So when you are moving this one, after keeping the object, you will fix the jaws, right? So after keeping the jaws fixed, so this V0 of the vernier scale will show some reading on the main scale. So that reading we call it as MSR, okay. So that reading we call it as MSR. Which reading? The reading on the main scale shown by 0 of the vernier scale, shown by or crossed by, we call it as. So whichever main scale division crossed by this vernier scale, we will be taking as MSR. And VC, VC is called as vernier coincidence, vernier scale division, which is matching with the one of the division of the main scale, any one, okay. That coincidence will be called it as vernier coincidence, okay. Whichever division, for example, consider that this is 4, so this 4 is matching with the main scale division, then this 4 is taken as VC. The division on the vernier scale which is matching with any one of the main scale division, so that division will be taken as vernier coincidence. After taking these two, after keeping the object, after taking these two measures, what should we do? We need to use this formula MSR plus VC into LC. MSR plus VC into LC. So MSR is the main scale reading which is crossed by the vernier 0, and VC is the vernier scale reading, not main scale reading, vernier scale reading which is matching with the main scale division, okay. So those two will be substituted with along with LC, so that you will get the total reading, okay. Total reading means the whatever the gap between those two jaws that you are finding. So what is the measuring way we need to do? So already explained this. Follow these steps for the perfect reading. Check for 0 error. I will explain later. Close the jaws and see if the 0 of both scales align. So when there is no object, 0, this jaw comes to attach with this jaw. So at that moment 0 of the vernier scale will match with the 0 of the main scale. That is exactly the vernier caliper should manufacture. Because of some manufacturing errors or because of some rough handling, this 0 doesn't align with the 0 of the main scale, it will be that side or this side sometimes. So in that case we will consider 0 error. First of all we need to check the 0 error is there or not, then fix the object between jaws, either this jaws or this jaws or tail, and note the MSR. First note the MSR. MSR should be noted like the vernier 0 passing the main scale division, that division should be considered as MSR, and VC, which division on vernier scale matching with the any division on main scale, that should be considered VC. So using that MSR and VC we can find the total reading. Now come to the errors. Errors in vernier calipers. Errors occur when the 0 of the vernier scale does not align with the 0 of the main scale when the jaws are closed. So when the jaws are at contact position, 0 of the vernier scale does not match with the 0 of the main scale sometimes. So in that case we will have a error. I will let you know some more precisely. For example, if you want to find the height of a person, assume that you have a vertical scale here, okay, like this, and you are keeping a person like this, and you will measure the height of that person. For example, if he stands on a pillar like this and try to measure, then what happens? His length seems to be increases, okay. If there is a dig, then his length may decrease, right? When he is on the pillar you will have a bigger reading, when he is in a pit you will have a less reading. So to get the exact reading, what should we do? We should subtract or add that length of the pit or length of that pillar, okay. So that will be mechanized according to this here. So here also the 0 of the vernier calipers may lie down or may lie up, okay. So when it is up you will have more reading, when it is down you will get less reading. So if you find the 0 error, then you can easily add or subtract based on the whether it is up or down, okay. I am saying this side as up, I am not saying this side as up, but consider this side as up. I will give you reason also. So consider coordinate axis. So this will be positive and this will be negative, and this will be positive and this will be negative. So if you consider this as up, on horizontal this as horizontal, you should consider this as up. So positive side should be considered as up, negative side should be considered as down. You will easily remember this, okay. So here in this, if you see 0 of the vernier scale lies left side of the main scale, in such case that is called as negative 0 error, okay. So when the 0 of the vernier scale lies left side, then it is called negative 0 error, because as I explained on axis. So here if 0 of the vernier scale lies left side of the main scale, then consider it as negative 0 error, okay. If it lies on the positive side, that side, right side, then that will be considered as a positive 0 error. As I implicated with the height of the person, so this is upside, this is downside. If he has a pole you will get more value, if it is a pit you will have less value, okay. So like that here also negative 0 error is taking out the exact reading and the positive 0 error is enhancing the exact reading. So now tell me which should be added and which should be subtracted. So here is on the pole, he measured the distance, so what should we do? This one we should subtract, right? And here it is in pit, so what should we do then? This reading should be added to the measured reading, so then only you will get the exact reading, okay. So now come to the conclusion. The 0 error is 0 marks align perfectly, no correction needed, but positive 0 error, vernier 0 is the right side of the main scale, vernier 0 is right side of the main scale, so it will be considered as positive 0, and it should be subtracted the error from the total reading. So whatever observed reading that you see, from that you need to subtract. And negative 0 error is vernier 0 is the left of the main scale 0, so it will be on left side, then it will be negative 0 error, it should be added to the total reading. So that error should be added to the total reading, means observed reading, okay. I will explain with the formulae. if you have a positive zero error, the formula that we need to follow is total reading or original reading is equal to observed reading minus positive zero error. If it is negative zero error, total reading or exact reading is equal to observed reading minus of minus zero error. So then the minus of minus will become plus, so you will be adding up. The minus of plus of minus will be minus only, so you are subtracting it. Okay, so that I am saying positive zero error value is positive, but you need to subtract from the original reading. Negative zero error is value is negative, but you need to subtract, then it will be finally added up. Okay, so you need to be aware about the values first whenever you are reading the question, then only you can easily find the exact reading. So one small thing is there here, everyone have to be aware about it. About the zero error, so many people are doing mistakes, but exact concept I want to explain now here. Please concentrate on this. So when the 0 of the vernier scale is matching with the 0 of the main scale, we will consider no error. Okay, we won't consider any error. But the problem comes when this 0 lies that side or this side, either positive side or negative side. Okay, assume that it has moved one division little bit that side. Okay, so one division, one small division, this vernier scale moved that side. Then which division is going to match? This first division is going to match. Then what is your error? This first division into least count, right? So obviously when it is having positive zero error, that means 0 lies on the right side, you should multiply the vernier coincidence with the least count, and this should be considered as a positive zero error. Okay, now okay, this is okay. Now come to negative zero error. When this 0 comes to this side, that is left side, which division is going to match? And this 0 just moves a little bit small, small division. For the small division like this, if it moves like this first one don't matches, but matches ninth one. This ninth one moves little bit, so it will matches with the 8th division of the main scale. Okay, so ninth one matches. So if you keep ninth one into least count, but the error is only 0.1, how could it satisfies? So in that case we need to follow, for the negative zero error, you need to take the number of vernier scale divisions minus that coincidence into least count, so that you will get 1 into least count, so that is 0.1 millimeter. So you have moved to left side with 0.1 millimeter, but you are getting coincidence on the 9th division. So if you multiply with 9, you will get a bigger value, which is a wrong value. What should we do to get the right value? Because you moved only for small distance only. So for that case, you have to do this number of vernier scale divisions on the scale minus coincidence into least count, so that you will get exact value or exact error. So generally people are doing that whenever they have given negative zero error in terms of a coincidence, they are just placing that coincidence and multiplying with least count. That is wrong. For negative zero errors, you should follow this one. For positive zero errors, you should follow this one. I will give a precise formulation here. So for example, if it is positive zero error, total reading is equal to observed reading minus plus whatever the coincidence you will do, you will measure into least count is the positive zero error formula. And for negative zero error, total reading or exact reading is equal to observed reading minus n minus coincidence into least count. This is what you need to apply the formula. If you confuse about here, that's all, you will get wrong value only. Okay, even NTA also did some mistakes. I will explain that one while doing PYQs. So this is the formula that you should follow when we are considering with zero errors. If it is principles or something else, that doesn't give you problem. Only the zero errors are giving problem here. You should be aware about that one. If at all NTA gives a wrong answer, just you should fight for that. As of now, we have discussed about the principle, least count formula, and total reading formula, and errors, and formula on the errors. So most of the PYQs are asked on these concepts only. A little bit problematic skill you need to use. With that you can easily secure the marks in this. Let's dive into the PYQs. The question is like this: 2014 6th April offline question. A student measured the length of a rod and wrote it as 3.50 centimeter. Which instrument did he use to measure it? So options are given. One is meter scale, vernier calipers and screw gauge with different pitch and different divisions. So here we need to consider the given thing first. A student measured the length of the rod and wrote it as 3.50 centimeter. So according to the concept, the given length is 3.50 centimeter. So up to the second decimal places, up to that precision the value exists. So we can consider from this the least count of the measured device would be 0.01 centimeter, because that precision tells the least count of that value. So from this, if you from the given 4 options, if you find whichever is having least count as 0.01 centimeter, so we can take that answer as a right answer. So now consider the first one. First one is a meter scale. So every meter scale is divided into 100 centimeters and each centimeter is divided into 10 parts, that is 1 millimeter. So that will be 1 millimeter, or if you convert centimeters, that is 0.1 centimeter only. So least count of meter scale. So meter scale would be 0.1 centimeter. So obviously that is not the least count. So first one is not the right answer. And come to the second one, vernier calipers, where the 10 divisions in vernier scale matches 9 divisions in main scale, and main scale has 10 divisions in 1 centimeter. So clearly it is telling that one main scale division is equal to 1 centimeter by 10 divisions in that main scale division. So you will get 0.1 centimeter as 1 MSD. And for least count, for a vernier calipers, least count is equal to 1 MSD by number of VSDs. So vernier scale divisions. From the given principle, it is clear that 10 vernier scale divisions are there. So you will have 0.1 centimeter divided by 10. So you will get 0.01 centimeter, which is matching with the measured least count. So answer would be second one. We can check the remaining 2 also. So in the remaining 2, a screw gauge having 100 divisions in the circular scale and pitch as 1 millimeter. So for a screw gauge, least count is equal to pitch by number of circular scale divisions. So here pitch is 0.1 centimeter, because 1 millimeter is given, so I am converting into centimeter. 0.1 centimeter divided by 100, so which gives 0.001 centimeter, which is not matching with the measured least count. So if we keep 50 as given in 4th option, if you keep 50, 0.1 by 50 will give 0.002 centimeter. So this is also not the given least count. So the answer for this question is second one, which is vernier calipers. The question is asked from 10th April online exam 2015. Diameter of a steel ball is measured using a vernier calipers, which has divisions of 0.1 centimeter on its main scale and 10 divisions on its vernier scale, matches 9 divisions on the main scale. 3 such measurements of a ball are given as. So 3 measurements are given which are measured with this vernier calipers. If the zero error is minus 0.03 centimeter, then corrected diameter is, we need to get the least count from the given vernier calipers and we need to measure what is the exact diameter that measured, and we have 3 instances, so we can take the average of it and then what is the error that is there we can subtract from it and we can get the exact measurement. Now so clearly it is mentioned that 1 MSD is equal to 0.1 centimeter and we have 10 vernier scale divisions. So least count is equal to 0.1 centimeter 1 MSD by number of VSDs, that is 10 here. So we will have 0.01 centimeter as least count. Now come to the given measurements. Here main scale reading is 0.5 and matched vernier scale division is 8. So from this we can say the measured value is 0.5 centimeter plus 8 into 0.01 centimeter, so which gives 0.58 centimeter in the first instance, and in next instance it is 0.54 centimeter, and in third instance you have 0.56 centimeter. So these three are the measured values. So here it is given that the vernier calipers is having zero error, that is negative zero error. So always we need to add the negative zero error to the measured value. So your values will become, here it is by adding this one you will have 0.61 centimeter, and here we have 0.57 centimeter, and here 0.59 centimeter. So by taking average of this one you will have mean of that diameter, which gives 0.61, 0.57, 0.59. so it is 17, and here it is 17.1, so 1.77 by 3 we need to take, which gives 3 5s are 18, 27, so 3 9s are 27. So this is the D mean, 0.59 centimeter. So we have 0.59 centimeter in the options also. This question is asked in 2nd September online test in 2020, shift 1. The least count of the main scale of a vernier calipers is 1 millimeter. Just keep an eye on here, the least count of the main scale of vernier calipers. Okay, it's not least count of the vernier calipers, it is the least count of main scale of the vernier calipers is 1 millimeter. Its vernier scale is divided into 10 divisions and coincide with 9 divisions of the main scale. When jaws are touching each other, the 7th division of the vernier scale coincides with the division of the main scale, and the 0 of vernier scale is lying right side of the 0 of the main scale. When this vernier is used to measure the length of the cylinder, the 0 of the vernier scale between 3.1 centimeter and 3.2 centimeter and 4th vernier scale division coincides with the main scale division. The length of the cylinder is VSD is vernier scale division. So we need to find out the length of the cylinder when it is kept between the jaws of the vernier calipers. When there is no object between the jaws, the 7th division is matching. So that means obviously this vernier calipers is having some zero error, and that is lying right side. So that means this vernier calipers is having positive zero error, and that should be subtracted from the observed reading. The least count of the main scale is given, that means one main scale division is given. One main scale division is equal to 1 millimeter. This is the least value that you can consider from the main scale. So obviously it is 1 main scale division, that is 1 millimeter. So we got 1 MSD, and the principle is also followed, like 10 VSDs is equal to 9 MSD, not 8 or not 7. 10 VSD is equal to 9 MSD. So principle is also following. So with this can we find the least count? Yes, least count is equal to 1 MSD, that is 1 mm divided by number of VSDs 10. So which will give 0.1 millimeter, that is the least count. And here 0 error we will consider. So here 7th division, when the jaws are at mean position, 7th division is matching. So least count into that error matching we can multiply. So least count is 0.1 millimeter into 7. So it is 0.7 millimeter is the positive zero error. So that I kept positive. And after taking reading, we have vernier scale 0 lies between 3.1 centimeter and 3.2 centimeter. That means your MSR is equal to 3.1 centimeter. Okay, 3.1 centimeter. Now we will consider VSR. VSR is equal to VC into LC. VC is 4th division is matching. So 4 into LC is 0.1 millimeter. So we will keep all the measurements in one unit system. So here the total reading is equal to, observed reading consists of these two. So 3.1 centimeter plus 0.04 centimeter minus plus 0.07 centimeter. I just converted millimeter into centimeter. So you have 3.1 and that you have to add 0.4, so you will get 3.14. in that you need to subtract that 0.07, so which will give 3.07 centimeter as the total reading. After subtracting positive zero error, we got the total reading, that is 3.07, that is the length of the cylinder. So which option has that value? So third one, 3.07 centimeter is the answer for that. So what we did here, we got least count, we got the principal. Okay, using least count we measured the observed reading, and you measured the error and you subtracted that error from the observed reading, so that we got total reading. This question is asked in 16th March 2021 online shift 1 exam. One main scale division of a vernier calipers is a centimeter and the nth division of the vernier scale coincides with n-1th division of the main scale. The least count of the calipers in millimeter is. So here one main scale division of a vernier calipers is a centimeter. So one MSD is given, one MSD is equal to a centimeters. In all measuring problems they will give numbers, but here they have given variables and general principle also. So here principle is also given, there is nth division of the vernier calipers coincides with n-1th division of the main scale. That means n vernier scale divisions is equal to n-1 main scale divisions. Asking to find the least count of the vernier calipers. So least count is equal to, for least count one MSD is a and number of VSDs are n. So it is in centimeter. We need to convert into millimeters. So which will be a into 10 by n millimeter is the answer. So direct answer only fourth one. This question is asked in 17th March 2021 online shift 1 exam. The vernier scale used for measurement has a positive zero error of 0.2 millimeter. If while taking a measurement it was noted that 0 on the vernier scale lies between 8.5 centimeter and 8.6 centimeter, vernier coincidence is 6, then the correct value of measurement is least count is equal to 0.01 centimeter. So directly it is given. They mentioned positive zero error, which is 0.2 millimeter, and least count is given, that is 0.01 centimeter. So all the options are in centimeter only. Just convert this positive zero error into centimeter, that is 0.02 centimeter, and least count is this much. So after using the vernier calipers, the zero of the vernier calipers crosses 8.5. So your MSR will be 8.5 centimeter, and your VC is vernier coincidence is 6. So your VSR is 6 into 0.01 centimeter, so which is 0.06 centimeter. Now the total reading is equal to observed reading, that is MSR 8.5 plus VSR, that is 0.06. So anyway it is positive zero error, that means it lies on right side. You need to subtract from the values, that is 0.02 centimeter. So which gives 8.54 centimeter. In the given options it is second one, 8.54 centimeter is the answer. This question is asked in 13th August 2021 online shift 2 exam. The diameter of a spherical bob is measured using a vernier calipers. 9 divisions of the main scale in the vernier calipers are equal to 10 divisions of vernier scale. One main scale division is 1 millimeter. The main scale reading is 10 millimeter and 8th division of the vernier scale was found to coincide exactly with one of the main scale division. If the given vernier calipers has positive zero error 0.04 centimeter, then the radius of the bob is. So here the diameter of the spherical bob is measured using vernier calipers. So between the jaws you kept the sphere and you will find the diameter first. Okay, we need to find out the radius of the bob, that means d by 2 we need to find out. That's what we need to find out. First, according to the given information we will find the diameter. So to find the diameter, the vernier calipers is following the principle. So 10 vernier scale divisions equal to 9 main scale divisions, and each main scale division, one main scale division is 1 millimeter. So with this we can find least count is equal to 1 main scale division by number of VSDs, which is equal to 1 millimeter divided by 10. So it is 0.1 millimeter or 0.01 centimeter. Now for the total reading, we need to find the MSR first. MSR is 10 mm. So 10 mm, I will convert into centimeter. So 10 mm is 1 centimeter, 1 centimeter plus VC while measuring is 8th matching, 8 into least count 0.01, and it is specifying that positive zero error is there. So it is 0.04. So whenever you have a positive zero error, you need to subtract the value from the observed reading, so which is 0.04 centimeter. So which gives 1.08 minus 0.04, which is 1.04 centimeter. So 1.04 centimeter is the diameter. We need radius, so we need to divide with 2. So radius is equal to d by 2, which gives 104 by 2, that is 0.52 is the radius. So but we need to specify in terms of 10 to the power of minus 2 centimeter. So here if I can write 52 into 10 to the power of minus 2 denomination, so after taking out you will have 52 here. So the answer is 52. Under the integer answer you need to put 52. Some students kept 104 directly because after measuring all the things, total reading, just they kept 104. The examiner is asking radius of the bob. Just keep aware about the question what is asked in it. This question is asked in 26th June 2022 online exam shift 1. In a vernier calipers, each centimeter on the main scale is divided into 20 equal parts. If 10th vernier scale division coincides with the 9th main scale division, then the value of the vernier constant will be, so integer answer question is given. So here in vernier calipers, each centimeter on the main scale is divided into 20 equal parts. That means one main scale division is equal to the unit, that is the pitch of the main scale, that is 1 centimeter divided by number of main scale divisions in that. So here you have 20, so which gives 0.05 centimeter. Okay, 1 MSD is equal to 0.05 centimeter. And then asking about vernier constant. Vernier's constant is nothing but least count. Least count is equal to 1 MSD by number of VSDs, which is equal to 1 MSD is 0.05 centimeter divided by, so here the principle is given, according to that 10 vernier scale divisions are there. So if you keep 10 here, you will have 0.005 centimeter. But asking about the format of 10 to the power of minus 2 millimeter. So first convert into millimeter, that is 0.05 millimeter, and it is 5 into 10 to the power of minus 2 millimeter. Take out this, only the number is 5. You should fill 5 in integer answer. So here the main scale is divided. Main scale measurements are centimeters. In that you have 20 parts in each centimeter. So with this you got MSD. Don't get confused about the MSDs and VSDs. And according to the principle, we got how many VSDs, and vernier constant is also called as least count. So least count is equal to 1 MSD by 1 VSD, number of VSDs. So you have this answer. And just keep an eye on unit conversion also. Okay, this question is asked in 2022 26th June online shift 2 exam. A travelling microscope is used to determine the refractive index of a glass slab. If 40 divisions are there in 1 centimeter on main scale and 50 vernier scale divisions are equal to 49 main scale divisions, then least count of the travelling microscope is dash into 10 to the power of minus 6 meters. So magnitude form is given, we need to find the integer that you need to substitute here. So here we need to determine the refractive index of the glass slab using travelling microscope. which will be similar to the vernier calipers. Here 40 divisions are there in 1 centimeter on main scale. So pitch is given, pitch is 1 centimeter, and number of main scale divisions in that pitch are 40. So with this 1 MSD is equal to 1 centimeter divided by 40 is the least division in main scale. And it is given that the vernier principle, so that is 50 VSDs, vernier scale divisions, are equal to 49 main scale divisions. So principle is also following. So with this we can conclude that there are 50 vernier scale divisions in the measuring arrangement, and asking to find least count. So least count is equal to 1 MSD by number of VSDs. Okay, so 1 MSD is 1 by 40 centimeter divided by 50, so which gives 1 by 2000, or 1 by 2 into 10 to the power of minus 3 centimeter we can write. But here the answer should be converted to meter first. So we will convert into meters. So if we convert into meter, you will have 0.5 with half and 10 to the power of minus 3, and if you convert centimeter to meter, you will have 10 to the power of minus 2 meters. So we have 10 to the power of minus 5, but in this 10 to the power of minus 6, still one more adjustment we need to do. That is, if you keep 5 aside, then you will have another 10 to the power of minus 1 here. So on a total you will have 5 into 10 to the power of minus 6 meters. So we have this section, so we need this one, substitute there. So that is the answer, 5 is the answer. So direct question only. They have given pitch and number of main scale divisions in that pitch, and principle is given. So with that we can easily find the least count. This question is asked in 29th June 2022 online shift 2 exam. The vernier constant of a vernier calipers is 0.1 millimeter and it has zero error of minus 0.05 centimeter. While measuring diameter of the sphere, the main scale reading is 1.7 centimeter and coinciding vernier division is 5. The corrected diameter will be. This is also integer type question. So main scale reading is given, MSR is equal to 1.7 centimeter, and VC coincidence is given, that is 5th division. Vernier constant of vernier calipers, that is 0.1 millimeter. 0.1 millimeter, which can be written as 0.01 centimeter. So if you multiply these two, you will get VSR. And apart from that, it is given like zero error, which is given in negative. That means it is negative zero error, which is minus 0.05 centimeter. So it's a negative zero error. Now we need to find the total reading. Total reading is equal to observed reading constitute these two, that is 1.7 centimeter plus 5 into 0.01, so 0.05 centimeter minus 0.05 centimeter, so which gives plus you will get, and 0.1 you will get. So 1.8 centimeter is the answer, but we should answer in terms of this. So here unit is centimeter only, so I am keeping 180 into 10 to the power of minus 2 centimeter to get the required format. So here answer is 180, the integer answer is 180. If it is positive zero error, you need to subtract from the observed reading. If it is negative zero error, you need to add to the observed reading. This question is asked in 26th July 2022 online shift 2 evening shift. In a vernier calipers, 10 divisions of vernier scale is equal to 9 divisions of main scale. When both jaws of vernier calipers touch each other, the zero of the vernier scale is shifted to the left of the zero of the main scale, and fourth vernier scale division exactly coincides with the main scale reading. One main scale division is equal to 1 mm. While measuring diameter of a spherical body, the body is held between two jaws. It is now observed that zero of the vernier scale lies between 30 and 31 divisions of main scale reading, and the sixth vernier scale division exactly coincides with the main scale reading. the diameter of the spherical body will be. So clearly they are asking about diameter of the spherical body which is held between a vernier calipers, which is following the principle. Okay, so 10 divisions of the vernier scale is equal to 9 divisions of the main scale. So it is also following the principle, and it has zero error, because when both jaws are touching each other, the zero of the vernier scale is shifted to the left of the zero of the main scale. So when the zero of the vernier scale shifts to the left of the main scale division, then we can call it as a negative zero error. So how to calculate the negative zero error, we will come to know. And here another thing is given. So after keeping the object, the reading, main scale reading is also given, and that coincidence also given. So we need to find out the diameter of the body after taking out the zero error. So first of all, we consider the principle. So it is following the principle. So 10 VSD is equal to 9 MSDs. So that means we have 10 vernier scale divisions on that vernier calipers. And next, both jaws are touch each other, the zero of the vernier scale shifted to the left of the zero of the main scale. So that is negative zero error. So as I said, whenever you are experiencing a negative zero error, and the coincidence, if we consider the coincidence, that is fourth vernier scale is matching with the main scale, so that should be subtracted from the number of vernier scale divisions and multiplied by least count. So here negative zero error is equal to number of vernier scale divisions minus matched coincidence into least count. So here number of vernier scale divisions are 10 and matched coincidence is 4, so which should be multiplied with least count. Okay, from the given information we need to find the least count. So one main scale division is equal to 1 mm. So 1 MSD is 1 mm, and we have 10 divisions on the vernier scale. So our least count will be 6 into 1 mm by 10, so which gives 0.6 mm. So that is the negative zero error. Now come to the measuring part, observation part. So here MSR is equal to, so here the zero of the vernier scale lies between 30 and 31 divisions. So we need to consider the 30th division as the main scale reading. So 30, so each division is 1 mm, so we can write 30 mm is the main scale reading. Now come to VSR. VSR is equal to VC into LC. Here vernier coincidence while measuring the diameter is 6 into least count is 1 mm by 10, so which is also 0.6 mm. So all the measurements are in millimeters only. So now total reading is equal to observed reading minus of zero error. So which is equal to observed reading is comprised of MSR plus VSR minus 0, negative zero error is so this much. So we need to subtract it. Every negative zero error should be negative, and that also should be subtracted from the observed reading. So we can write like this: 0.6 mm, and here MSR is 30 mm and VSR is 0.6 mm, and plus minus of minus plus 0.6 mm, which will give 30 plus, so if you add these two you will have 1.2 mm. So on a total you will have 31.2 mm. If you convert to centimeter you will have 3.12 centimeter. I think no answer is there, so nearest one is this one. There seems to be some miscalculations here by the examiner, because whenever there is a negative zero error you need to subtract the matched division from the number of vernier scale divisions. So he didn't do, I think, so you will get 4 there, and 4 plus 6 is 1, so you will get 31 only. 31 means 3.1 centimeter only. So I think NTA did mistake here. The main concept, as I discussed in the concept level, whenever it is a negative zero error you need to subtract that matched division from the vernier scale, number of vernier scale divisions. If you put it directly without this you will get wrong answer only. NTA has to look into it. This question is asked in 27 July 2022 online shift 1 exam. One division of main scale of vernier calipers reads 1 millimeter, and 10 divisions of vernier scale is equal to the 9 divisions on main scale when the two jaws of the instrument touch each other, the 0 of the vernier lies the right of the 0 of the main scale and its fourth division coincides with the main scale division. When a spherical bob is tightly placed between the two jaws, the 0 of the vernier scale lies in between 4.1 cm and 4.2 cm and 6th vernier division coincides with the main scale division. The diameter of the bob will be. So obviously it is asking about diameter, that means whatever the reading that you will get between the jaws, that is the value, and given one division of main scale of the vernier calipers reads 1 mm. So 1 MSD is equal to 1 mm, which is 0.1 centimeter, and 10 divisions of vernier scale is equal to the 9 divisions of main scale. So with this we have 10 VSDs matching with 9 MSDs. So with this LC is equal to 0.1 centimeter by 10, which is 0.01 centimeter as least count. So here after touching the jaws, 0 of the vernier calipers lies right side of the 0 of the main scale. That means it's a positive 0 error. It is lying on the positive axis right side, so it is positive 0 error. So positive 0 error is equal to matched division is 4th and 4 into least count is 0.01 centimeter, that is equal to 0.04 centimeter is the positive 0 error. That means we need to subtract this one from the observed reading. So here observed reading is when a spherical bob is tightly placed between the two jaws, the 0 of the vernier scale lies in between 4.1 centimeter and 4.2 centimeter. That means MSR is 4.1 centimeter and VSR is so 6th vernier division coincides. So 6 into 0.01 centimeter. So now total reading is equal to observed reading 4.1 centimeter plus 0.06 centimeters minus 0 error, positive 0 error. So 0 error which 0.04 centimeter. Subtract from this, you will get 0.02 here. So it is 4.12 centimeter. So in the answer it is mentioned like number into 10 to the power of minus 2. Convert this one 412 into 10 to the power of minus 2 centimeter. Take out this, answer is 412. So here you need to fill 412 in integer answer. This question is asked in 29th July 2022 online shift 1 exam. A travelling microscope has 20 divisions per centimeter on the main scale, while its vernier scale has total 50 divisions and 25 vernier scale divisions are equal to 24 main scale divisions. What is the least count of the travelling microscope? So a small twist is given here, that is here travelling microscope has 20 divisions per centimeter. So 1 MSD is equal to 1 centimeter by 20. So 0.05 centimeter is the value of 1 MSD. Now here it is given, so vernier scale has total 50 divisions on it. So number of vernier scale divisions are 50, but principal, according to the principle, 25 vernier scale divisions are equal to 24 main scale divisions. Okay, principle is 25 vernier scale divisions is equal to 24 main scale divisions. So here then 1 VSD is equal to 24 by 25 MSD. So here 1 VSD value is this much. But if you follow according to one formula, least count will get deviated. Here we have two formulas for least count. Least count is equal to 1 MSD by number of VSDs. Okay, so if you follow here, you will have 0.05 by 50. But if you follow one formula like 1 MSD minus 1 VSD, which is 1 MSD is 0.05 centimeter minus 24 by 25 into 0.05. You need to follow here so you will have 0.05 by 25, you will get 25 into this much. If you take 0.05 centimeter as common, so you will have 25 minus 24, that is 1. So remaining is 0.05 centimeter by 25. So we are getting clash here. So which should we follow? So the main reason is we need to follow the principle, okay, not the direct formula. we need to follow the principle first. Whatever the principle says, we need to follow according to that. The principle says this one, 25 ESD is equal to 24 MSD. So with that you will get a least count as this much, because when you use such type of vernier scale, you will have two matching divisions when you are measuring a measurement. Okay, two matching divisions on vernier calipers. So in that case we should follow only the principle, what principle says. So according to the principle, least count is 0.05 by 25. Okay, so now from that what is the least count of the traveling microscope? That is 0.05 by 25. So which gives 0.002 centimeter is the least count, 0.002 centimeter. Third one is the answer. So many students did mistake, so they followed this one, so they put 0.01 centimeter, but that is not the answer. 0.02 centimeter is the answer, because whatever may be the measurements or whatever may be the pitch or whatever may be the main scale division, we should follow the principle first, then only we will get exact least count. If you use, even though a device which has such type of physical state like having 50 divisions on vernier scale, but when you are measuring, two divisions will be matching, so that you won't get the right thing. If you follow this one only, then you will get the right thing. This question is asked in 10th April 2023 online shift 2 exam. In an experiment with vernier calipers of least count 0.1 millimeter, when two jaws are joined together, the zero of the vernier scale lies right side to the zero of the main scale, and the sixth division of the vernier scale coincides with the main scale division. While measuring the diameter of the spherical bob, the zero of the vernier scale lies in between 3.2 centimeter and 3.3 centimeter marks, and fourth division of the vernier scale coincides with the main scale division, the diameter of the bob. So we need to find the diameter only, that means the measurement between jaws only. So here vernier calipers least count is given, least count is equal to 0.1 millimeter, so which is 0.01 centimeter, and zero of the vernier scale lies right side of the zero of the main scale, that means it is a positive zero error, which is equal to sixth division into least count, so which is equal to 0.06 centimeter is the positive zero error. And while measuring the MSR is equal to, the vernier zero lies between 3.2 to 3.3, so it is 3.2 centimeter is the MSR, and the VSR is equal to, at that time VC is 4 into 0.01 centimeter, which is 0.04 centimeter. Now the total reading is equal to, MSR is 3.2 plus VSR is 0.04, and zero error is 0.06 minus 0.06, so which gives 3.2 minus 0.02, which is 3.18 centimeter. So the answer is 3.18 centimeter, the second one. This question is asked in 27th Jan 2024 online shift 2 exam. Given below are two statements, one is labeled as assertion and other is labeled as reason. Assertion: in vernier calipers, if a positive zero error exists, then while taking measurements, the reading taken will be more than the actual reading. Yes, it is true, because whenever positive zero error is there, the zero of the vernier scale lies right side the zero of the main scale. That means it is showing some reading even though the jaws are at mean position. So you have some reading already. Whenever you are keeping an object, it will show more than that the actual reading. So the observed reading is more than that the actual reading. So you need to subtract that positive error from the observed reading. So whatever the statement that mentioned here, it is true. In vernier calipers, if positive zero error exists, then while taking measurements, the reading taken will be more than the actual reading. Yes, TR is less than observed reading, so that you are subtracting positive zero error from the observed reading to get total reading. And come to the reason, the zero error in vernier calipers might have happened due to manufacturing defect or due to rough handling. Yes, zero errors will be happened because of the manufacturing defect. While making, the laser cutting of the dimensions may move this side or that side, so you will have manufacturing defect error, or due to rough handling also. Whenever the students or people are handling roughly while measuring the objects measurements, some sort of bendings or something happen, because of that you will get a error. So this is also true. Okay, how the errors are happening and how to handle that positive zero error from the observed reading, that also mentioned. So clearly assertion and reason are true, A is true, so both A and R correct, and R is the correct explanation of A. Option is 1. This question is asked in 30th Jan 2024 online shift 2 exam. If 50 vernier divisions are equal to 49 main scale divisions of a travelling microscope and one smallest reading of main scale is 0.5 mm, the vernier constant of travelling microscope is. Clearly asking about the least count. So least count is equal to 1 MSD by number of VSDs. So here principal is given 50 VSDs equal to 49 MSDs. So clearly we can keep this 50, and main scale, on main scale smallest division is 0.5 mm. So 1 MSD is equal to 0.5 mm, and given options are in centimeters and millimeters only. Okay, so do the problem first. So least count is equal to 1 MSD is 0.5 mm divided by 50 VSDs, so which gives 0.01 mm. 0.01 mm. Yes, fourth one is matching. If it converts to centimeter, it has to be 0.001 centimeter. Is there any centimeter mentioning like that? No. So the answer is fourth one. It's a direct question only. This question is asked in 1st February 2024 online shift 1 exam. 10 divisions on the main scale of a vernier calipers coincides with 11 divisions on the vernier scale. If each division on the main scale is of 5 units, the least count of the instrument is. So it's not a regular way of asking question. The principle is 11 VSD is equal to 10 MSDs. Okay, so 11 VSD is equal to 10 MSD. So 1 VSD is equal to 10 by 11 of MSD. So we got 1 VSD. We need MSD, 1 MSD here. If each division on the main scale is of 5 units, so 1 MSD is equal to 5 units. So your least count is equal to 1 MSD minus 1 VSD, which is 5 units minus 10 by 11 into 5 units. So you have 5 into 1 minus 10 by 11, which is 11 minus 10, 1 by 11. So 5 into 1 by 11 or 5 by 11 units is the least count, 5 by 11. So fourth one is the answer. 1 MSD from the main scale, and with the principle we got 1 VSD, but not in a regular way. Regularly we will use 10 VSDs equal to 9 MSDs. Okay, but this is not the way, but actually it is following the principle. What is the principle? N VSD is equal to n minus 1 MSD. Okay, so 11 VSD is equal to 11 minus 1, that is 10 MSDs. So it is following the principle, so that they mentioned this correctly. So with that we got a least count. This question is asked in 5th April 2024 online shift 2 exam. A vernier calipers has 20 divisions on the vernier scale, which coincides with 19 divisions on the main scale. The least count of the instrument is 0.1 mm. One main scale division is equal to, just twisted, that's it. So here the principle is 20 vernier scale divisions is equal to 19 main scale divisions, and the least count is given. Least count is equal to 0.1 mm. Okay, so even asking the answer in terms of mm only, so no need to change the unit. We need to find 1 MSD. 1 MSD is equal to, from the least count formula we have least count into number of VSDs, which is equal to least count is 0.1 mm into VSDs are 20, So which is equal to 2 mm is the answer. So 1 MSD is 2 mm here. This question is asked in 6th April 2024 online exam. In finding out refractive index of glass slab, the following observations were made through travelling microscope. 50 vernier scale division is equal to 49 main scale divisions, 20 divisions on main scale in each centimeter. For mark on paper, MSR is equal to 8.45 centimeter, VC is equal to 26. For mark on paper seen through glass slab, MSR is equal to 7.12 centimeter, VC is equal to 41. For powder particle on the top surface of the glass slab, MSR is equal to 4.05 centimeter, VC is equal to 1, MSR is equal to main scale reading, VC is vernier coincidence, refractive index of the glass slab is. It's a totally combination of optics and this instrumentation. First of all, from the given instrumentation, principle is 50 VSD is equal to 49 MSDs. So with this we can clear that there are 50 VSDs which are following principle. Next, 20 divisions on main scale in each centimeter. So 1 MSD is equal to 1 centimeter divided by 20, which is 0.05 centimeter, that is 1 MSD. So with this least count is equal to 1 MSD, that is 0.05 centimeter divided by 50, which gives 0.001 centimeter or 10 to the power of minus 3 centimeter, whichever easy we can use that. And these are the dimensions or given values for the given microscope. Next, we made, using this vernier calipers, we made 3 observations of the glass slab. Those are as follows. Okay, first one is the mark on the paper. So they have considered a paper and on it they considered a mark. So used travelling microscope here. Okay, used travelling microscope and observed that reading. So that reading is like consider that reading 1 is equal to, or T1 is equal to MSR, that is 8.45 centimeter plus coincidence is 26. So 26 into 1 by 1000. Okay, so 1 by 1000 centimeter, which gives 8 point, so this is 0.026. so if you add this one you will have 476. 8.476 centimeter is the first reading when you don't keep that slab. So after keeping the slab, they observed the rise of this mark with a reading 2, where you have observed like 7.12 is the main scale reading and MSR, and VC is 41. So 41 into 1 by 1000, which is 0.041. If you add to this you will have 7.161 centimeter. And after that they measured the top of this block. So that is T3 is equal to, for that you have MSR as 4.05 centimeter plus VC is 1 and LC is 1 by 1000, you equal to 4.051 centimeter is the third reading. Okay, we got 3 level readings. This is T1 and raised mark is T2 and the top of the slab is T3. So to get the real height you need to subtract T3 from T1. So real depth is equal to T1 minus T3, which is 8.476 minus 4.051, 524.4, 4.425 is the real depth. Now apparent depth is equal to T2 minus T3, which is 7.161 minus 4.051, which gives 011.3. So 3.110 is the apparent depth. Asking about to find the refractive index. What is refractive index formula? Refractive index formula mu is equal to real depth by apparent depth, which is equal to, real depth is 4.425 by 3.110. So it is nearly 1.4 or 1.5 is coming. So what is the answer? Okay, we have nearest values. Now we need to do the math, like 3.11, 4.425, ones are 3.11, so you have 1 3.1 here. If you keep point here, you will have 13.1. so 13 you will get 4 times of this. 4 times 4 ones are 4, 4 ones are 4, 4 threes are 12. So here you have 6, here also 6.0. so now, so by multiplying with 2 you have 2 ones are 2, 2 ones are 2, 2 threes are 6. So 0. So nearly we got 1.42. Now the answer is 1.42. So it's a roping up of optics and measurements. Just to concentrate your valuation on while doing math. The question is asked from 6th April 2024 online shift to exam. In a vernier caliper, when both jaws touch each other, 0 of the vernier scale shifts towards left and its fourth division coincides exactly with a certain division on main scale. If 50 vernier scale divisions equal to 49 main scale divisions and zero error in the instrument is 0.04 mm, then how many main scale divisions are there in 1 centimeter? So clearly examiner is asking about number of main scale divisions in the pitch. First of all, we will get the information from the question. So here from this we can say that the pitch is 1 centimeter. So pitch is equal to 1 centimeter. So we already know that 1 MSD is equal to pitch by number of MSDs. So how many parts in that pitch we need to take to find the value of 1 MSD. But here we know pitch, we don't know number of VSDs and even 1 MSD also from the information, but we need to find out number of MSDs. So if we reshuffle this formula, number of MSDs is equal to pitch by 1 MSD. So if we know 1 MSD, then we can easily find number of MSDs. Now come to the information, if any information is given or not. So there is 0 error in the instrument and saying that it is on the left side. Vernier 0 is the left side of the main scale division. That means this error is negative 0 error. So given negative 0 error, given error is negative 0 error, so which is 0.04 mm, which means 0.004 centimeter also. So let it be like that. So every 0 error will be finding with a formula that is VC into LC, right? We have 0.004 centimeter. So 0.004 centimeter is equal to VC into LC. So vernier coincidence is given, but that is for negative 0 error. So whenever the vernier coincidence is given for the negative 0 error, we need to subtract the given coincidence from the number of VSDs. So which is here number of VSDs minus coincidence into least count. So that's what we need to evaluate. And here the principle, according to the principle, there are 50 vernier scale divisions. So here I can write 50 minus 4 because 4 is the coincidence into least count. So from these calculations we can have least count is equal to 0.004 by this is 46. So this is least count. Now we have least count. So what we find from least count? Least count is having another formula which is 1 MSD by number of VSDs, right? So from least count we have another formula to be compared with this value. Now come to here. So we have number of VSDs, that is 50. So 1 MSD is equal to, if you reshuffle, you have 50 into 0.004 by 46 is the 1 MSD, and put that MSD here. So we need number of MSDs is equal to, pitch is 1 centimeter. So 1 centimeter divided by 1 MSD is 50 into 0.004 by 46. just reshuffle it, 46 by, and this is 1 0 it goes, and 5 4s are 20, so you will have 0.2 here. So 46 by or 460 by 2, that is 230 main scale divisions, but there is no answer here. I think here also NTA did the mistake because they are not subtracting the error coincidence from the number of VSDs divisions. That should be done according to the concept. Whenever you have a negative 0 error, whenever 0 of the vernier scale lies left side of the main scale 0, you should subtract that coincidence from the number of VSDs. That's what the concept is. But NTA is not doing that. They are doing directly, like they are not subtracting this, they are doing directly. So if you take such type of solution, 0.004 centimeter is the given error, and you have coincidence is 4, and we have LC. So LC, from this LC is equal to 0.004 by 4, so which is 0.001 centimeter. Okay, so from this if you compare 0.001 by 1 is equal to 1 MSD by number of VSDs. So number of VSDs is 50. If you bring to here, 1 MSD is equal to 50 into 0.01, you will have 0.5 centimeter as 1 MSD. So 1 MSD is 0.5 centimeter. So number of MSD is equal to 1 centimeter by 0.5 centimeter will give 20 divisions. Okay, so I think this is what the method NTA followed. They didn't subtracted that one, so that they got 20, which is the answer here, third one. But it is conceptually wrong. 20 is conceptually wrong. So as discussed in the concept, NTA is not following exact concept here. This NTA has to look into it. This question is asked in 8th April 2024 online shift 1 exam. The diameter of a sphere is measured using a vernier calipers whose 9 divisions of main scale are equal to 10 divisions of vernier scale. The shortest division on the main scale is equal to 1 millimeter. The main scale reading is 2 centimeter, and the second division of vernier scale coincides with the division on main scale. If mass of the sphere is 8.635 grams, the density of the sphere is. So here we need to find the density rho, which is mass by volume. So mass is given like m is equal to 8.635 grams, and volume we need to find out for that sphere. So for that, what is the formula? 4 by 3 pi r cube is the formula, volume formula for that sphere. We need to find out the radius using this vernier calipers. So but with using vernier calipers we can find the diameter, then we can find the radius, or else just directly you can write 4 by 3 pi t by 2 whole cube, which gives, so this is 8, so 1 by 2, and this is 8, 6, 1 by 6 pi d cube is the volume of the sphere. Anyway, the unit for the density is measured in gram per centimeter cube, so if we keep all the measurements under centimeter. Now using vernier calipers we can find the diameter, and the vernier calipers properties are like according to the principle 10 VSD is equal to 9 MSD. So we have 10 VSDs. Here the shortest division on the main scale is equal to 1 millimeter. That means 1 MSD is given. 1 MSD is equal to 1 millimeter, which is equal to 0.1 centimeter. Least count is equal to 1 MSD by number of VSDs. So this is 0.1 centimeter by 10, which is 0.01 centimeter. We got least count. Now the reading, total reading or diameter is equal to main scale reading is 2 centimeters. So MSR is 2 centimeters plus, and VC is at second division. So 2 into 0.01 centimeter is the VSR, which is equal to 2.02 centimeter is the diameter. If you keep that one here, you will have 1 by 6 22 by 7 into 2.02 whole cube centimeter cube. So now density rho is equal to mass is 8.635 divided by 1 by 6 into 3.14 into 2.02 whole cube. So this is the substitution. So 2.02 whole cube will come nearly 8.63 only. So I am just cancelling that one. So this one will be 6 by 3.14, which is nearly 2.0 something. So the answer would be first one. So I just calculated roughly. You just try to calculate with a calculator or with precise calculations so that you will get the answer, exact answer. The difficult part is calculation of this one only. Remaining everything you can do easily with our previous experience. This question is asked from 8th April 2024 online shift 2 exam. Least count of a vernier calipers is 1 by 20 n centimeter. The value of one division in the main scale is 1 millimeter. Then the number of divisions of main scale that coincide with n divisions of vernier scale is. So it is given that least count of the vernier calipers as least count is equal to 1 by 20 n centimeter. The value of one division on the main scale is 1 mm. So 1 MSD is given, which is equal to 1 mm, or in terms you can write 0.1 centimeter. And then the number of divisions of main scale that coincide with the n divisions of vernier scale is. So directly it is giving n divisions of vernier scale. N divisions of vernier scale should match with n minus 1 divisions of main scale, right? But n minus 1 is not there. That means this is special type of vernier calipers where too many divisions which are following the principle, not n divisions. Not only n divisions, there are other VSDs are there which are matching with the MSDs. That other number we need to find out. So now I am checking this LC, least count. Generally least count formula is 1 MSD minus 1 VSD. This is one formula. Or you can go for 1 MSD by number of VSDs. Okay, we have two formulas. So given least count is 1 by 20 n, so we will try both whether we get any expression or not. So here from the first equation, least count is 1 by 20 n, which is equal to 1 MSD is 0.1 centimeter minus 1 VSD. Bring that 1 VSD here. 1 VSD is equal to 0.1 centimeter minus 1 by 20 n centimeters. So this is VSD, which is equal to, I can write 1 by 10 minus 1 by 20 n here. By taking LCM, you have 20 n here, here 2 n, here 1. So 2 n minus 1 by 20 n centimeters is the value of 1 VSD from the first formula. Principle is assume that x VSDs are interacting with or matching with x minus 1 MSDs. Okay, we don't know the value, that's what we need to find out. This we need to find out. Okay, first of all, according to principle, we are assuming that x VSD is matching with x minus 1 MSDs. From here, 1 VSD is equal to x minus 1 by x into MSD. Each MSD is 0.1 centimeter. So which is equal to x minus 1 by x into 1 by 10 centimeters. This is 1 VSD. So here we got with n relation, here we got some x relation. For the VSD, now equate both. X minus 1 by 10x is equal to 2n minus 1 by 20n. 10 2's. Okay. So if you separate this bases, you will have x by x minus 1 by x is equal to 2n by 2n minus 1 by 2n. 2n gets cancelled, x gets cancelled. 1 minus 1 by x is equal to 1 minus 1 by 2n. Take out 1 here and minus then. So your x is equal to 2n. So that means 2n VSDs are matching with 2n minus 1 MSDs, or n VSDs are matching with, if you bring 2 here, 2n minus 1 by 2 MSDs. So NVSDs are matching with this one. If you go according to the principle, it's not there. That means some number of VSDs are matching with some number of MSDs. So we got that relation using this LC, and later we got NVSDs. In fact, in question is they are asking about NVSDs only. So NVSDs are matching with these many MSDs, 2n minus 1 by 2. So the answer would be the third one, 2n minus 1 by 2 is the answer. Little bit complicated one only, but you should observe properly, you should relate properly. Okay, so this relation is failing, you don't have the answer. So that means either you need to extract from the least count or you need to extract from the actual principle. We did the same. From LC we got one expression for the 1 VSD, and from general relation we got an expression for the 1 VSD, we equated, and then we got the relation for x and n. So generally x VSDs, that means 2n VSDs are matching with 2n minus 1 MSDs, and according to the question n VSDs are matching with 2n minus 1 by 2 VSDs. This question is asked in 2024 9th April online shift 1 exam. One main scale division of a vernier calipers is equal to m units if nth division of main scale coincides with the n plus 1th division of vernier scale. The least count of the vernier calipers is. So here one main scale division is given, that means 1 MSD is equal to m units. It's not millimeter or centimeter, just they mentioned units, m units. And then giving principle that n plus 1 of VSDs equal to n MSDs. Asking about the least count of the vernier calipers. So least count is equal to, you can write 1 MSD by number of VSDs. Okay, if you write 1 MSD, that is m by number of VSDs like n plus 1, so m by n plus 1 is the answer. So where is the option? Third one is the option. Even if we go with another formula like least count is equal to 1 MSD minus 1 VSD. So from here 1 VSD is equal to n by n plus 1 MSD. So if you substitute here, least count is equal to 1 MSD is m minus VSD is n by n plus 1 into m. So if we take LCM n plus 1, this is mn plus m minus mn, which gives m by n plus 1. So in both cases we got the same answer, that is third one, m by n plus 1 is the answer. Please check once. Okay, whenever you are finding an answer, just recheck the answer so that it will be confirmed. This question is asked in 22nd Jan 2025 online shift 1 exam. Given below are two statements, statement 1 and statement 2. So we need to find out whether those are true or false. Statement 1 says, in a vernier calipers, one vernier scale division is always smaller than one main scale division. So utterly it is false. The principle is n VSD is equal to n minus 1 MSDs. Okay, this is the principle that we should follow. So 1 VSD is equal to n minus 1 by n MSD. So lesser number by bigger number will give a number which is less than 1. Okay, so 1 VSD which is equal to a decimal number or less than 1 number of MSD, that means small part of MSD is equal to 1 part of VSD. So it itself tells that 1 VSD is very much less than 1 MSD. Every vernier caliper should follow the principle. So based on the principle, 1 VSD should be less than 1 MSD. So this statement is false. So statement 1 is false. Next one, the vernier constant is given by one main scale division multiplied by the number of vernier scale divisions. So in least count, vernier constant means least count is equal to 1 MSD by number of VSDs. Okay, but here in the statement they are multiplying, so that means this is also false. So both statements are false. So the answer is, both statement 1 and 2 are false. Answer is third one. Simply conceptual, directly we can answer this. Easiest question. This question is asked in 2024 NEET exam. In a vernier calipers, n plus 1 divisions of vernier scale coincide with n divisions of main scale. If 1 MSD represents 0.1 mm, the vernier constant in centimeter is. Just like the above questions, whatever the mains questions are there with slight change, they are asking in NEET also. So here, according to the principle, n plus 1 VSDs are equal to n MSDs, and 1 MSD is equal to 0.1 mm or 0.01 centimeter, which in turn written as 1 by 100 centimeter. All we should know in centimeters. So vernier constant is least count, should be mentioned in centimeter. Least count is equal to, we will follow 1 MSD by number of VSDs. So 1 MSD is 1 by 100 and number of VSDs are n plus 1. So 100 into n plus 1 is the answer. So 1 by 100 into n plus 1, second one is the answer. As I said earlier, we need to check the answer in other way. Least count is equal to 1 MSD minus 1 VSD. So which is equal to 1 MSD is 1 by 100 centimeter minus, from the principle it is n by n plus 1. 1 VSD is 1 by n plus 1. So n by n plus 1 into 1 MSD is 1 by 100. So if you bring out 1 by 100 as common, you will have 1 minus n by n plus 1. So if you take LCM, n plus 1 on the top, n plus 1 minus n. So n gets cancelled, 1 by n plus 1 will be there. So this is 1 by 100 into n plus 1. So in both ways we got the same answer. The least count is 1 by 100 into n plus 1. This question is asked in 4th April 2025 online shift 2 exam. For the determination of a refractive index of glass slab, a travelling microscope is used whose main scale contains 300 equal divisions equals to 15 centimeters. The vernier scale attached to the microscope has 25 divisions equals to 24 divisions of main scale. The least count of the travelling microscope is. So principle is given, that is 25 VSD is equal to 24 MSDs. Okay, principle is following, and there according to the given thing on main scale, pitch, that is 15 centimeters, pitch is 15 centimeters, which is divided into 300 equal parts. Okay, so your 1 MSD is equal to pitch by number of MSDs. So pitch is 15 centimeters divided by 300 divisions are there. So 15 ones are, 15 20s are. So here you will have 0.05 centimeter as the 1 MSD. Okay. Now we need to find out the least count. Least count is equal to 1 MSD is 0.05 centimeter divided by number of VSDs are 25. So which is equal to 0.002 centimeter is the least count. So the answer is second one, 0.002 centimeter is the answer. So main testing is this one. So you should follow the value of 1 MSD should be equal to pitch by number of MSDs. So we substituted that one, we got 1 MSD. With that we can easily find the least count.